solving a system of equations by graphing. And we are going to be focusing on linear systems. So here we have two equations, and we want to figure out the solution. Remember, the solution is the point or points that both lines have in common. So to figure this out, we're going to use graphing. Both of these equations are in slope-intercept form. So in order for us to graph, we need to identify the slope and y-intercept. Slope of the first equation is 1. And I like to write it as a fraction, 1 over 1, because when we build our line, we need to use the rise over the run. The y-intercept is 2. For the second equation, slope is 3 over 1, and the y-intercept is negative 2. So now we're going to graph. And I'm going to start with the first equation. So go to the y-intercept, so go to where y is 2. And we're going to build the line using slope. So we're going to rise 1 and run 2. Now, we want to build a nice long line. So there are many possible places that the second line could intersect this original line. So if we make a little short line, we're not going to see all of those possible places. So here's the first line. And then go to where y is negative 2. And rise 3, run 1. Rise 3, run 1. Oh, look, we found the point of intersection, so I'm going to do it one more time. Rise 3, run 1. Now, don't stop here. We need to find the solution. We found that there is one solution, because there's one place that these lines are touching, but the question is, what is the solution? The answer to that question is the ordered pair. So 1, 2, 1, 2, 3, 4. So 2, 4 is that solution. What that means is if you plug in a 2 for x and a 4 for y for both equations, those are the only two numbers that will give you true statements on both sides for both equations. Okay, so the next system, again, go through, find slope and y-intercept. So 2 over 1, 4. Slope is 1 over 1. Y-intercept is 2. So again, graph your first line. Go to where y is 4. And then we're going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Come back to the original point, do the opposite. Down 2, run to the left 1. Down 2, run to the left. Again, you want a nice long line, so you have lots of possible places for intersection. Okay, second line, go to where y is 2, and up 1 to the right. Now, I can see that if I keep going this way, I'm not going to touch. My lines are not going to touch each other. So I'm not going to keep going using the positive direction. I'm going to kind of do the opposite. So opposite of up is down, opposite of right is left. And I can see if I keep doing this, I am going to come to a place where the two lines intersect. Again, there is one solution, but I need to know what that solution is. So this is negative 2, 0. Okay, here's another system. And again, both equations are in slope-intercept form, so we can easily find slope and y-intercept. Slope is 2 over 1, y-intercept is 2. Here, slope is 2 over 1, and y-intercept is negative 1. So let's graph. Go to where the y-intercept is 2, and build our line using a slope of 2. So up 2 to the right 1, up 2 to the right 1, come down, do it again, down 2 to the left, down 2 to the left. I want a nice long line. So the second line had a y-intercept of negative 1, and the slope is 2. So up 2 to the right 1. Look at this. These two lines are never going to touch each other. What makes these lines parallel is that they have the same slope. So if you happen to notice that at the beginning, when you're graphing, you do not need to make really long lines. Just plot 3 or 4 of the points, show that it's parallel, and your answer here then for the solution, there is no solution. These lines will never touch. In our last system, this first equation is not in slope-intercept form. So before we can figure out slope and y-intercept, we got to rearrange this equation. So we want to make it y equals mx plus b, y equals. So add x to both sides, 2y equals x plus 2. Solve for y, divide by 2. Divide everything on the right by 2. So this is going to become y equals 1/2 x plus 1. Slope is 1/2, y-intercept 1. For the second equation, slope is 1/2, y-intercept is 1. Look at that. Same slope, same y-intercept. That means that these are going to be the same line. So again, I already know the solution. There's going to be many solutions to this equation because all points along that line are true for both. But I still need to show by graphing. And again, I do not need to make a super long line. And I don't need to do it twice. So build the line, start where y is 1, and go up 1 to the right 2. Up 1 to the right 2, come back to the opposite. Down 1 to the left 2.